Okay, so it is time to start taking some quizzes in Chapter 5, and I have just a little bit of a review for the first quiz. It's going to cover Chapter 5, Section 1 through Section 3, and going to start out asking you about what multiplicity really means. And if you have a real zero of even multiplicity, then the graph is going to touch the x-axis. So what that means, if you're looking at the function and you have a binomial that is squared, that has a multiplicity of 2. An even multiplicity, that means the graph is going to touch the x-axis at 5. It's going to bounce off the x-axis. Okay, over here, this is an even multiplicity, going to bounce off or touch the x-axis at -3. And touch is the vocabulary word that MyLabs Plus will use. Over here, we've got some binomials of odd multiplicity. At -1 on the x-axis, the graph would cross the x-axis. With this binomial, the multiplicity is 1. If there's no exponent, it's assumed to be a 1, and that will also cross the x-axis at +2. Okay, determine whether this function is a polynomial. So yes, this is a polynomial. It has 2 terms, but it's written kind of odd. We want it to go, the exponents to be in descending order. So I'm going to move this around and rewrite it like I have in red here. And then we can see the largest exponent is 3, so the degree of this polynomial is 3. And the lead term is the first term after you write it in descending order. And the constant in this case is 0. A couple more examples. Over here, a lot of students think that this is a rational function, but since the denominator does not have a variable, we can write this as a polynomial. And so I'm going to take the first term, x squared, and put it over 3, 6x over 3, and 9 over 3. So I'm going to look at this polynomial right here. The greatest exponent is a 2, so it's a degree 2, and the lead term, 1/3 x squared, constant is 3. In this next example, the square root of x, that is not a polynomial. The square root of x can be written as x to the 1/2. And so remember, with a polynomial, the exponents are not allowed to be negative or fractions. And remember, fraction and rational mean basically the same thing. So this is not a polynomial. You still have to transform functions. So if I have x to the 5th, I just graphed that on my calculator and have a little function looking like this. And if I have x to the 5th minus 7th, that function is just going to shift down 7 units. But you can graph it on your calculator, just make sure you know what's going on. Okay, this is a good problem. This polynomial has 3 zeros, and it's going to be a degree 3. And they want you to find the function. So the first thing you need to do is take each of these solutions, these x-intercepts, and write it in binomial form. Then I'm going to take this first binomial and multiply it by the second by FOILing. So first, outside, inside, and last. So that's going to give me this polynomial. The x minus 6 is just going to kind of sit there and wait. And I'm going to group these 2 terms in here. So now I'm going to take this x squared and distribute it over to the x and get x cubed. Then I'm going to take this x squared, distribute it to the -6. I'm going to move on to the middle term, -x times x, -x times -6. I'll move on to the -2. So the -2 times x and -2 times the -6. And I'm just going to group my like terms right here, my x squared term and my linear terms, And there's my final answer. So this first step is pretty easy, but be very, very careful when you're doing all of your multiplication. Okay, so is this a polynomial? Yes, a polynomial is a nice continuous function. It's a degree 3, 1, 2, 3. I like to count the increasing, decreasing paths of the polynomial so that I can tell my degree. I see that it's crossing the x-axis at 0 and touching the x-axis at 3. That's why I would use this 3 twice, a multiplicity of 2. Remember, down here, this is not a polynomial. Polynomial graphs don't have holes, gaps, or jumps, or these cusps or sharp corners. Okay, just a rule. When a polynomial function is divided by this binomial, we're not going to do the long division right now just because of everything that's going on with COVID-19. So what we want to do is a shortcut. So I'm going to take C and plug it into the function, and that gives me the exact same number remainder that I would get if I did use long division. So this next example, kind of confusing. Use the rational zeros theorem to find the potential rational zeros, the possible roots, not the exact roots, but just the possible ones. If there is a rational solution, it will be in this list that we're going to find. So we're going to take the lead coefficient, and that's going to be P. P is 1. Then we're going to look at the constant and call that Q. So Q is 9. Take the factors of the lead coefficient and put them in the denominator. Take the factors of the constant and put that list in the numerator. And then we're going to divide. 1 divided by 1 gives us 1. 3 divided by 1 gives us the 3. And 9 divided by 1 gives us 9. So if this function has a rational solution, it's either going to be plus or minus 1, plus or minus 3, plus or minus 9. I know that there's no way it could be a 2 or 4 or 5. It can only be in this list. Okay, so every polynomial function that has an odd degree is going to have at least one real zero. That's a rule. So if I have like x cubed or any polynomial x to the 5th, x minus 1 to the 7th, it will touch in one place at least. Now it might touch in 3, it might touch in 5, whoops, but it will always have at least one real zero. And then we've got our nice complex number, 8 plus 4i. If 8 plus 4i is the zero of a polynomial function, then 8 minus 4i is also. These are conjugates of each other. And if one complex number is a solution, then we definitely know its conjugate is also a solution. And that's about it. It's a pretty easy quiz to take, so study up and go take that quiz.